Now in this video, we're just going to demonstrate the basic property of the capacitor. For this one, to keep an LED lit, you want as large of a value capacitor as you can. Really, 1,000 microfarad is about as large as you get. So it takes 1,000 microfarads. It's the same as a millifarad, but for some reason they stay in the microfarad range. It would take 1,000 of these to equal 1 farad, which would be a supercapacitor. This is probably close to about the maximum capacitance you would use with a regular circuit. So in any case, we have the capacitor there. With the switch open, the capacitor will be discharged when you come to the circuit as far as it can go. The LED takes a little bit of voltage to conduct, and so when the capacitor discharges, it'll stop where the LED needs to conduct. But in any case, when we close the switch, the capacitor will instantly charge, at least charge as fast as it can, and depending on how much current the power source can provide, and as it charges, you'll get that current going through the load right there. So almost instantly, the load's going to turn on, and then current will flow freely. Remember, we'll have the switch closed. Current will keep flowing freely during that period of time. But here you can see that within the capacitor, there's a couple plates. And this is a symbol for a polarized capacitor. If both lines are straight, that indicates a non-polarized capacitor, which you need if you're going to charge it in either direction. But here, we have to keep the one side that doesn't have the gray bar down here with the little dashes. That has to be more negative down there. And then the other side up here has to be more positive when you charge it. So, in any case, let's do a quick demonstration. The power supply is to 12 volts right there. And here we have the circuit that I drew the diagram for too. So you can see the resistor comes up to the capacitor, that jumper, long lead of the LED, that's why I left that a little longer there. The anode to the resistor, short lead, the cathode there. If you put it in backwards, the LED won't light up, and 12 volts might even destroy the LED if you put it in backwards. So don't do that. But in any case, we'll do our demonstration. So now I'm applying power. And it looks like pretty much instantly the LED came on, and here you can see that we got about 9 milliamps of current, so this may waver a little bit, but in any case, there you have that. And when I yank this, you're going to see the meter drop to a 0 pretty much instantly, as quick as it can, but we still got power going. So right now the LED is being lit by the capacitor, so we'll apply power again. Now as soon as I moved the jumper away, all the power was provided by the capacitor. You can see the LED was bright at first and gets dim over time. So the capacitor builds up a voltage based on how much charge difference there is on the plate. So this is a 1,000 microfarad capacitor. I also have a 100 microfarad capacitor, so we can compare the time difference. So otherwise, they'll operate basically the same. And if there was a little delay in the LED lighting up with the 1,000 microfarad, the 100, there'd be less of a delay. And so in any case, it still lit up pretty quick. Now when I remove this, as soon as I removed it, you can see it did stay bright for just a little bit, quickly went dim, and it wasn't dim near as long as the 1,000 microfarad capacitor. But otherwise, the circuit was the same. It just stored less energy. Again, this is kind of wavering between 9 and 8 at different times, and so it's probably really close to about 9 milliamps. This is usually off about 1 milliamp, but in any case, that was the demonstration. Let's compare this again with the 1,000 microfarad for timing right there. So it stayed lit for a little bit, but got dim pretty quick. And then with the 1,000 microfarad, there's a little trickle going through right there, and now we got probably about 10 times as long. When you have the same load, 10 times the capacitance, it'll take about 10 times as long for its voltage to change. So this is just a demonstration of the basic property of the capacitor of storing a little charge, a little energy, and a little bit like a rechargeable battery, but you don't use capacitors like a rechargeable battery. We're more interested in the time. As you saw, this one takes about 10 times as long to make a voltage change. If we use more resistance, it would take even longer. So you adjust the time for circuits, topics for other videos. Other than that, I'll post some other videos for you to check out to the screen. Make sure you check them out. Click like, subscribe, the bell, all that. Donate Patreon if you can. That helps out the most. I have links down in the description. But just watching videos helps out a ton. Thanks to everybody that does that. I will see you in the next video.